Find all the solutions of f of x. So here we have a fourth degree polynomial, and we need to find all the solutions. When you're doing this, all right, I'm going to do it. I don't have a calculator on board, but when I was doing this, you can look at the possible real rational zeros, right? And what you do is, we talked about this in class, and you take 12, the last term, and divide it by the first, coefficient, and you look at the factors of those. So 12, what can you multiply together to get 12? You can multiply 1 and 12. You can also multiply 2 and 6, right? Or you can multiply 3 and 4. So those are the factors of 12. And then the factors of 1 is just 1, right? So basically, I know that if the zeros here are real, whatever are the real rational zeros are going to be plus or minus 1, positive or negative 1, positive or negative 2, positive or negative 3, positive or negative 4, positive or negative 6, positive or negative 12. That would be the possible real rational zeros, right? Now, let's say, well, in this situation, we're trying to find all the zeros, and I have my calculator, but because I can't put it on the screen, I'm not going to worry about it, and I'm going to just show you how to do it if you didn't have a calculator. Now, you can use your calculator to narrow down these zeros, but we're going to use synthetic division. So we have 1 for this coefficient of 1, negative 7, right, for this, 18, negative 22, and 12, right? And we're doing synthetic division. And I'm going to just start off the list and choose 1, and we're going to see if this works, right? So the first one comes down, 1 times 1 is 1. Add those together, you get negative 6 times 1 is negative 6. Add those together, you get 12 times 1 is 12. Add those together, you get negative 10 times 1 is negative 10. So this one does not work because your remainder is not 0. So positive 1 does not work. So I would just erase this. And then I try a different number. So negative 1. 1 comes down, 1 times 1, negative 1 is negative 1. Those add together to give you negative 8. Negative 8 times negative 1 is 8. Those add together to give you 26 times negative 1 is negative 26. You can kind of already see that this isn't going to work, right? Because these two add together to give you negative 48, right? That's not going to work. So it's not negative 1, it's not positive 1. So then we go to the next one, right? 2, positive 2. So this comes down as 1. 1 times 2 is 2. Add those together, you get negative 5. Negative 5 times 2 is negative 10. Add those together, you get 8. 8 times 2 is 16. Add those together, you get 6. Ooh, negative 6. All right. Negative 6 times 2 is negative 12. So that one does work. All right. So x equals 2 is a solution. Bam. Or an x-intercept, the point 2, 0. Since this thing the question was find all the solutions, we found it. X equals 2 is one solution. All right. Now, this brings this overall polynomial down to a third degree polynomial. So that's not enough for us to factor it yet. It's 4 terms, which this is 1x. Oh, excuse me. This is 1x to the third, and this is x squared. This is x, and then this is, so that's not we can't factor that yet. So we keep doing synthetic division. I call this compound synthetic division. We do it again, and we're looking for another 0. So we just did 2. Now we can go through the list and choose negative 2. And we just do it again, right? 1 comes down. 1 times negative 2 is negative 2. That gives me negative 7. That gives me 14, right? Add those together, you get 22. And I see that's not working. right? It's not going to give me 0. So I'm bringing it out. Then we go to 3. Trying 3 now. So 3, right? It was 1, 2, 3. All right, 3. 1 comes down. 1 times 3 is 3. Add those together, you get negative 2. Negative 2 times 3 is negative 6. You add those together, you get 2. 2 times 3 is 6. All right, we just found one. This is 0, so we know x equals 3 is a solution. Now, like I said, in your calculator, if you graph this overall polynomial, it'll show you where the solutions are, wherever the x-intercepts, and then you have a lead. Now, can you say on your test or in your whatever, can you say, oh, x equals 3 is the solution, x equals 2 is the solution, and that's it? No. You got to have proof, right? It's in my calculator. That's not proof. All right, but you doing synthetic division is proof. So I did some of these, and it didn't get me anywhere. If you saw it in your calculator first, you wouldn't have to do those. You could go right to the ones that you suspected were solutions. So you wouldn't have to, waste any time there. But now we have 1x squared minus 2x plus 2, right? And now we can do whatever we can do. First, I don't put the 1 there, but now we can try to factor this. So, since it's quadratic, we know how to solve this. We can try to factor first. X times, so I'm looking for 2 numbers that I can multiply together to get 2, that when I add them together, I get negative 2. Well, the only thing I can multiply together to get 2 is 2 times 1. But when I add those 2 together, I don't get negative 2. So that tells us you can't factor. Can't factor. So what can you do? Well, you got 2 options. You can do quadratic formula, or you can do completing the square. Now in class, I feel like the last time one of these showed up, we did quadratic formula. But I like completing the square too. I don't think you should count anything out. So this time we're going to complete the square. How do you complete the square? I'll tell you. You got x squared minus 2x plus 2, and we're trying to, we're solving this thing, so we set it equal to 0, right? Because that's what I want my y value to be. Normally the y value is, f of x equals this. I'm setting the y value to 0 because I'm looking for x-intercepts, and all x-intercepts have a y value of 0. All right, so I'm going to get this 2 over here, right? So this is x squared minus 2x. I like to leave space, and I like to put parentheses. You don't necessarily have to put the parentheses, but you definitely should leave the space. And then this is negative 2, right? And then I take this linear term, negative 2, right? And I divide it by 2. Always going to be dividing it by 2 and squaring it. So that's negative 1 squared, which is 1. So I add 1 here, and then I add 1 on this side too. What you do to one side, you do to the other side. Or if you do it to one side, you also have to undo it on the same side. I could have, instead of saying plus 1 over here, I could say minus 1 right there, but that wouldn't make a whole lot of sense for me because I want the 1. So instead, I'm going to say plus 1 on this side as well. Now I can factor this, and I'm saying, okay, what 2 numbers can you multiply together to get, x and x always gives us x squared, right? Then I'm saying, what 2 numbers can you multiply together to get 1, but when you add them together, you get negative 2. All right, so 1 times 1 is 1, and if you add them together, you get 2. So negative 1 times negative 1 is positive 1, and when I add those together, I get negative 2. So it's a negative 1 and another negative 1, which I can just write as x minus 1 squared, right? That's why it's called completing the square. If you remember the little shortcut, it's always going to be whatever it is right here before it's divided by 2. Or I'm sorry, before it's squared, excuse me. And this thing equals negative 1, right? Just bring that down. And now I'm solving for x, right? How do I get x by itself? I can take the square root of both sides. So this is x minus 1, because the square root and the square cancel out, equals Now, anytime you create a square root, you got to remember it's a positive and a negative get created. And then the square root of -1 is just I. So x is equal to, you move that 1, so 1 plus or minus I. So we got two solutions there. Remember, imaginary solutions always come in pairs. That's x equals 1 plus I and x equals 1 minus I. So, if you were to graph this, you'd probably think this polynomial was funny looking, right? I'll kind of tell you, I'll kind of sketch out a graph of it, just, real quick. So I know it has a solution of 2, 1, 2, 3, 4. All right, I'm going to just go to 5. I know it has a solution of 2, an x-intercept of 2, and it has a solution of 3, right? So it looks like this. Now, these imaginary solutions, they don't show up on the graph. Don't show up on graph. Remember, imaginary solutions are in a different plane of existence, right? The imaginary plane. Are they real? Yes, they're real. Do you see them? No. I kind of think of them like ghosts. Are they real? Yes, they're real. Yes, 100%. But do you see them? Nah. You can take a picture of them. I don't know. You know what I'm talking about. All right. So now graph, right? Well, remember what we learned about end behavior. The positive leading coefficient means that this thing is ending going up. And because the degree is 4, I know it has to start that same way. And it also tells me that I have a y-intercept of 12, right? Y-intercept of 12. So I know it's going to go through this point, which is 12. So how's my graph going to look? I'm going to do it in this yellow color. It's going to look something like this. It hits that, and then it's going to kind of do a little curve or something right here. And then it has to turn around and then hit that. So it's going to look a little weird. It's probably not going to look like your normal graph because it has some other stuff going on. Something like that. Something like that. That's how it would look. Similar to that, we're only getting a rough picture because I'm only getting the x-intercepts, the y-intercepts, and the end behavior. But that's what we got here. So sometimes, that's what we got. All right, I hope this was helpful to you. So we found 2 real solutions, and then we also found 2 imaginary solutions. Imaginary solutions don't show up on the graph. Imaginary solutions always have what's called a conjugate, right? Gotta sound it out. Gosh. Conjugate pairs, right? They always come in conjugate pairs. So the irrational solution. Anytime you're going to take that square root symbol, right? If it was -5, -1, or if there was let's just say that there was a 5 in here, you still would have had a conjugate pair, right? But it was a -1. So I hope this makes sense to you. Good luck. All right.